In this video, we want to find the value of the unknown for these 5 problems. So we'll be using some properties of logarithms along with the definition of a logarithm. So for the first one, we have the log of 1000 is equal to x. We want to find the value of x. This is to base 10. If there's no log indicated, it's always base 10. So from the definition of log, we know that 1000 has to equal to whatever this base is. It's base 10 to the x power. So 10 to what power gives us 1000? Well, it's 3. So the unknown in this case is 3. X equals to 3. The next one, again, same sort of thing. We have the log of 1 over 64 to base 4 is equal to x. What is the value of x? The unknown. So by definition of log, I know that 1 over 64 has to equal to 4 to the x power. You can figure it out that way, or you can rewrite the 64 as 4 to the negative 3. We have a base of 4, a base of 4, so the exponents have to be equal. So x has to equal to negative 3. 4 to the negative 3 is 1 over 64. So you could actually gotten it from this right there. At x equal to negative 3. Number 3 again, definition of log. 27 has to equal to the base taken to the value on the right, which is 3. So what number to the third power gives me 27? B equal to 3. Number 4, I have e to a power ln of x is equal to 4. I want to find the value of x. Again, this is a property of logs, which is based on the fact that the exponential and the logarithm function are inverses. So this base here is e, and then the base of the logarithm is the same. Then the answer to the left side is x. So e and e tells me that the left side is equal to x. The right side is whatever it is. In this case, it's 4. X equal to 4. And number 5 is a logarithmic equation. The base is the same. We have a sum of 2 logs. There's a property that tells us then if you have a sum of 2 logs, you can write that as a single log to the whatever base it is. Base has to be the same here as 3, and that's going to equal to the product of those expressions. So the property tells you that if you have the log of a product of 2 expressions, you can break that down as a sum. So I can go from this step here back to this one, if that's what they tell you. But in this case, I want to put this together in order to solve for x. Because I have a sum, and I can write it this way. Log of the product of those expressions. If this were a minus, then this would be x over x minus 2. And this is 1 here. So now I'm going to go from log form to exponential form. Again, in this case now, next step we'll be using the definition of log, just like in the first 3. That tells me then that x times x minus 2 should equal to this base, which is 3, taken to the value over here, which is 1. So it's 3 to the 1 is 3. Now we multiply these out, we get x squared minus 2x. And we add minus 3 to both sides, and bring the 3 over, makes it a minus 3 equal to 0. Now we just have a quadratic equation to solve. So I can factor this into x minus 3 and x plus 1. Then we set each factor equal to 0, because we have a product equal to 0, then one factor has to be 0, or the other has to be 0, or they're both 0. So we set each factor equal to 0 here. And we add 3 to both sides here, we get x equal to 3. And on the other one, taking the 1 over, adding negative 1 to both sides, we get x equal to negative 1. X cannot be negative 1 though, because if you try to check this, you put with negative 1 in the first expression, first log, gives me the log of a negative. The log of a negative is not defined. It doesn't matter what the base is, you cannot take the log of a negative number. So this one, we reject. This one should work. It's positive 3. Let's double check it here. We put it in the first one. The log of 3 to base 3 is equal to 1, because 3 to the 1 will give me the 3. And if I put 3 here, 3 minus 2 is 1. The log of 1 to any base, in this case base 3, it's always going to be 0. So I get 1 plus 0 gives me 1. It checks. So this is my solution. X equal to 3. Thanks for watching. We'll see you next time.